Hello, I am Jaden and this is my Vibzcheck app presentation. Now, what is Vibzcheck? Vibzcheck is a communal listening party app that utilizes the Spotify API to create a collaborative listening party for any social occasion. The point for this app is that any user can connect to the queue and add tracks and then vote on it to see what the next song that should be played with, and it's made to create a sense of community or party or belonging, allow everyone to listen and feel like they're a part of something bigger than themselves. Once a song accrues enough votes, it will be added to the top of the recommended list, therefore adding ease of access to see what song has the most amount of votes and what song should be played next. The key features of the app is that it is a collaborative playlist app. It has a real-time updated song queue. There is song voting, so it's straight up democracy. There's no conflict within selecting the song. There is a Spotify web API integration. There is a room sharing protocol I put so you can share your code with other people so they can join the room. And there's also a dark mode toggle. Now, initially, the build sequence. I implemented features in a layered order to reduce the risk of any implementation in the future. I started with the Firebase authentication so I can get some background data working that I did a lot of testing with to make sure all the app displays were running correctly and I can see everything that I was doing in the background showing up in the foreground. And I also built the playlist creation system and the song management system within the Firebase database. And sorting it that way really allowed me to see what was being added, how it was being added, and how it was being handled within the app, and how the API was also affecting the Firebase backend. So it was easy for me to see what I was doing as I was not only testing the app, but also just trying to use it in a normal use case sense. But Firebase also allowed me to create a notification system so that users can be notified if another user adds to the queue or if a song was voted on, or I can myself send notifications to users using Firebase. So to rework a lot of my features, I did use the playlist screen as kind of the central hub for my testing, and then in turn that became the central hub for the usage of the app since I spent so much time in there testing the features, testing layouts, testing buttons. I naturally felt like just making the playlist testing screen I used into the actual physical screen that should be used to use the app in a normal use case sense, I felt like that was the best course of action. So everything that the user will interact with was tested and polished on the playlist screen. That's where everything is going to be for the user. And this screen was also helpful for me because as I was implementing so many minor or major different features, the screen became cluttered and I had to think of a lot of workarounds. Like the one that is being displayed, I had to turn the playlist screen from a bunch of windows, for lack of better terms, of information. I was able to turn those into buttons or scrollable sections of a screen to repurpose the space, not put too much, but also not put too little on the screen, so everything was easy for the user to understand. A synchronizing bug that I encountered was the chat system. As I was trying to not only implement the chat system within itself, but to make it that you could see usernames within the chat system, the chat would often break if it was utilizing an older build's chats. So I would have to go in Firebase and delete old chats, resend new chats every time I wanted to test a build. And that really slowed me down through development because I was struggling trying to find what specifically in the chat that was going wrong. So the playlist screen did become too large, like I said before, because I was putting so much testing into it, and it naturally, like I said, felt like the perfect place to put a lot of the actions that the users would use. It had way too many things on it, but information was clipping through other boxes of information, such as the recommendation, would not even render sometimes. The song list, it was about like 10 pixels long on the screen, and you could only see about half of the song title. So it was essentially rendered useless by the time I had implemented half of the features, like the manual adding the song and then the Spotify button. It was just too many things on one screen that it would just clip a lot of important information, and it felt really clunky and felt really unprofessional. So all that was turned into buttons into separate screens, and I only wanted basic information that you would want to open up and see immediately, not anything you would want to look for. Just, I wonder what song's on top of the queue right now. You'll open it up immediately, you'll see what the top 3 songs are in queue and how many votes they have. Or if you want to immediately add a song manually through the text option and not use the Spotify searching API, you can manually add it immediately through there. Now, this is an actual physical demo of my navigation structure. So under my manual text boxes of adding a song, you can search from Spotify. It that utilizes the API and a special search code I would have to put in so that my app could have a key to actually utilize the Spotify API, because Spotify does have a decent bit of security. They don't really let anybody use the API. You have to have a Spotify account and use certain keys to even access the API. And I also had the view songs and vote button, because that was the entire queue, not just the top 3 queue. That was the screen that was getting cut off. It was getting sandwiched between the fully extended chat box before it was a button, it was a box. Getting sandwiched between the chat box and the recommended songs, those 2 boxes took priority over the entire song queue. So I took that out and turned it into a button that you would see above the recommended songs, because it just felt naturally to go with all the song information at the top. And then the chat, as a more of a secondary feature, was a button on the bottom. So it could still be prominent and still be used, but I wanted the song features to take front and center. And his navigation structure also lended an easier implementation process, because it just allowed me to kind of add things in that open space or add things where I felt made sense. I also added a dark mode toggle and a log out button on the top of the screen, which we will see later in my full-on app demo. But it really lends itself to be kind of like a foundation or building block, if you will, which is why I call it the hub, because it felt really easy and really natural to build from the playlist screen. That was where I spent most of my time coding and developing. The front end was the playlist screen. It just felt simple and easy to add everything from there. Now, for the security and who can even use the app in the first place, I used Firebase authentication with user ID control access. And the playlist data is also linked with user ID. So when I make a playlist I tested this with 2 separate accounts, and each account I tested with has its own user ID linked to the playlist. So I can see who created the playlist, what they named it, when they named it, what songs they added to it, what messages, what user sent, because it all had user ID. And since logging in also creates and utilizes the Firebase authentication system, if you do not log in, you cannot access the data or access the playlist. So it kind of creates a safe and secure environment, so you don't want anyone joining your playlist when they shouldn't, messing up your playlist, adding things they shouldn't be adding, or it kind of just creates a more safe and secure environment on the app. Like I discussed before, one of my major failure cases was the chat box not rendering because I wanted to implement a username system. So initially what happened was when I sent a chat, it sent the user ID that was being stored in Firebase, and it did not send a username, whether that be an email or a name the user set. It was not a user ID. So what I did was implement a cover. So it would take the user ID and then give it a username based on what the user input for their login. I currently have it set to unknown user as a fallback in case it cannot get any user information to set itself to a name. The crash occurred in the first place because the UI was accessing missing data and it didn't really know what to do when it had the missing data, so it just gave me a bad state, which is what that box on top was. It was trying to access data, it didn't find it, so it would just throw up a bad state, and it wouldn't clear itself until I went through and cleared it manually. Then it has no more bad state to check. The username space is now empty. When I sent a new username upon that new build, then it knew what to do. It was a very incremental kind of testing phase. But now that I implemented it, it's very easy to tell what the message is, who sent it, because it's not saying that like 20 character long code of user ID. For my Firestore structure, I use collections and subcollections. This is what I was discussing earlier. So in addition to my users, I have the playlist, and then every playlist has a document name, and these document names are actually the playlist room codes. So through implementation, if I made several different playlists. If I wanted to go back in a certain playlist I made, I could simply go to the Firestore console and take any of these playlist document IDs, put that in as the room ID, and that would allow me to purposefully jump into an old playlist I had made to check on my implementation, make sure old things I was implementing before a new feature wouldn't break, and make sure it displayed correctly when I was changing the format or changing the way it was supposed to respond to a certain code I was inputting or certain input I was giving to the app, and making sure everything was working seamlessly together. So as the playlist is a collection in itself, the sub-collection of messages and songs also allows me to see what message is being sent and what songs are being added. When I click on the song sub-collection, I can see when the song was added, who added the song, the title of the song, and the artist that made the song. In the message, I can see the user that sent the message and the text contents of the message. So it's a really useful and interesting tool that kind of gives me like a bird's eye view on what is really happening in my app when I use it or when other people use it. It takes a long string of codes and IDs, and it gives me simple string tags so I can read it and interpret it in a human manner. And breaking it down into these collections and sub-collections make sure that I don't have a bunch of high level collections and creates a whole bunch of clutter in one menu. I can break it down point by point by point, and it's just really easy to interpret. Now for my authentication and security, I did use the Firebase authentication system. I used the email and password. I did want to implement the Google authentication, signing with Google, but there was a couple extra hoops that I had to jump through that didn't feel like a proper use of time while making this for a school project. But later, of course, if there was more time, I would implement that. That is a great feature, is an ease of access feature, but I personally felt for the sake of project that it was not the best use of my time to go through and implement the Google sign-in option. But the Firebase authentication I did utilize its authentication rule called request auth UID, and this is the rule. And the main acting force of this rule is allow read write if request time. This essentially says that Unauthorized users cannot use anything in my app. So in this case, a playlist room ID and the data and the songs and the users and the messages within that playlist ID. This is so, like I said before, it is a closed off yet communal environment. My app handles notifications depending on the state that the app is in. Now, if the app is open, it will utilize a snack bar and send you a message on the bottom, like the message right there. I did a different user testing, and I had one user when I was testing, one user um, on a as a separate app. So I had two users, so to speak, and that is the snack bar notification when the app is open. It says new song added, and I did the testing again when the app was closed in foreground testing, and that is new song added, a user has updated the queue. So this is great to just give simple, quick information whether the app be open or the app be in someone's pocket, should they be dancing, partying with other people, or managing a party. It's good to see what is going on in your playlist queue to make sure, again, there is no nefarious activity or unwanted activity going on in your communal playlist. And these are handled respectively by a listener and then a background manager. Now, as for my Spotify web API implementation, as I discussed before, I had to make a Spotify developer account. Well, I had an existing Spotify account as just a standard user, so making a developer account was quite simple as it was just an extension of my user account. But a developer account is also very simple as that's easy as setting up any other account, and it has a client ID and a client secret that I had to input into VS Code, which actually connects my app to the Spotify API, which is, like I said before, this is the security measure to make sure that it's not just this super open API, just accessing anyone can access the Spotify API, potentially mess with the files of the app you're using or the Spotify backend servers, just to create a more safer environment. Um, One strange thing that I did run into was that it needed a redirect URL. I do not have a redirect URL for my app because it doesn't really need it at this point in time. So I was able to find a just placeholder URL online that other people had used, and it was example.com/callback. And the API I used, I put web API, but if you wanted in-app playback, you can use Android and iOS SDKs to physically play songs through Spotify in your app natively. And here is my application demo. So upon opening the app for the first time or logging out of the app, I have my email and password sign up. So upon using the app for the first time, I have my email and password sign up. Or if you do have the account, you can hit the login button and then you can log in with an existing email and password. And both of these features do work. When I created a new test user through the sign up function, that did go to my Firestore. And when I had used two predetermined accounts, that also did work within my login function. And as soon as they log in, they are greeted with the playlist name creation or the playlist join button. So once you create the playlist, you can type the name of the playlist, then that gets sent to Firestore, creates a room ID. Like I said before, it stores your playlist name with that room ID. Or you can join a playlist with an existing ID, which is the time saver for me and the greatest part of implementing the app for me was the join playlist feature because I can go in Firestore, take the document ID, which I then later found out was the room ID, and that was my time saver to just input the room ID, stick to 3 separate playlists that I was testing new features on. And once you get into a playlist, whether you created it yourself or you join one, it was the interaction hub, as I dub it. So as we're looking at it, we have the room ID with a copy pastable button that goes to your phone's clipboard. There is a dark mode toggle button. There is a log out button that does have user confirmation. Then below that, we have a manual song title and artist input system. So you type your song, you type your title, you type your song, you type your artist, and you hit add song, and then it goes to the queue, which you can view in view songs and vote button. And you could also search from Spotify. You can type in the song and or artist, and it will do, I believe it was about 15 to 20 close matches songs. And under that, you have a recommended songs list. So all these songs are voted on by my initial account. And in the demo video, we will see me going on my secondary account and also adding and voting to this playlist that we are looking at right now. So you can see the screenshot for my initial account. I was just using it as if it was a solo user using it. And then the demo video was recorded on a second account so you can see how that looks when someone else joins a room. One early decision that gave me a lot of technical debt was putting too much functionality within my interaction hub. Like I said before, it cut off a lot of information. It made me had to rework a lot of different buttons, the way a lot of different information was formatted. It's just creating a lot of rework confusion that wasn't the most difficult things to implement. It was just figuring out, okay, where do I want this button to go? How do I want this information to be displayed? How do I want this information to be conveyed to the user? It was more so of a logistical issue of where do I want these items? How do I want these items to look? And how do I want the user to access them? How easy do I want the user to access um, certain things? And it was resolved easily just by, like I said, just creating different buttons and windows and a scrollable recommended list. I did not scroll in my demo video, but the recommended list is a scrollable list because depending on the device you use it on, that recommended list does get cut off if you're just looking at the top three. So it is scrollable, so you can adjust your view of everything. So no information is cut off. It's just behind a simple action of maybe a scroll, or maybe a button tap, or maybe a few words on the keyboard. Some known issues I did have was that messages do tend to display as sent from unknown, and that the mood tags are not visible or widely utilized within the app. Some future enhancements that I would like to put in my app is a user profile with a consistent naming system. This is a very easy and obvious addition as to why I would have this. Just if you have a bunch of people and you don't know who exactly everyone is in your chat box, you can see who's chatting. I would also like to add a joinable public playlist list. So, say the app runs on a server or things of the sort, you can see public playlists that people have set to public, or maybe someone set to private. It won't show up on that list. I think that would be a cool feature to maybe have like a spontaneous icebreaker as you're walking past someone who has an open Vibzcheck playlist. I would like to add audio previews in app by using the Spotify SDK options, like the Android and iOS SDK options. I think it would be very useful to say if you wanted to add a song to a queue that maybe you know by heart or no one else knows in the party, it would be easy and cool to just hit the play button and have the Spotify 30-second SDK preview run in the app. And it's easier from that point to say, hey, maybe we should add this song, maybe we shouldn't add this song. I would like to add a Spotify based color scheme, as I myself use a lot of third party Spotify apps to enhance my Spotify listening experience and Spotify usage experience between my phone and my computer. And they're all Spotify colored. Most of them are Spotify colored, and I think that would just be a good idea. A cool thing to make it feel more connected with the Spotify API that it is utilizing. And finally, I would like to implement a safer Spotify ID implementation within my code, because once I implemented it into the code, GitHub did not necessarily like the way I implemented it. It feels that it's a unsafe implementation, so that is definitely something I would want to go back and strengthen up um, at a future time. Thank you.